Now that we've explored using the gradient boosting and random forest with the IRIS data set, let's explore using it with a real data set. So we're going to revisit our friend the insurance data set, predicting who's going to crash their car and what's it going to cost. We're just going to take a brief look at a brute force approach of just who's going to crash their car. It's going to be a yes or a no. Again, this is not the way that you're going to want to do this. You're not going to do it this approach, but again, the purpose here is to show you the technique so that you have an understanding. Then we're going to, in the next video, talk about how to do this the easy way. So we're going to start off by looking at random forest. And again, do not do this. This is not what you want to do. You're not going to do it this way. There's a better way. But this is how this is being shown you for demonstration purposes. First, we are going to read in the actual data itself. And this is the insurance data set. So this has been already scrubbed. This is the data set we've used in previous videos. So there's no missing values here. All of the missing values have been fixed. We have done one hot encoding on all of the variables like single parent and the jobs, etc. So this is all ready to go. So what we're going to want to do is we are going to first, we are going to use a holdout sample here. So we're going to use 70% of the data for training purposes, and 30% will be our test sample. So let's start off like that. Oops. So if you see, if I do a dimension of the training data set, you can see we have 7,171 of those records are going to be for training, and we've got 46 variables in our data set. Our test data set is going to have 3,000 records. Okay, now let's build a random forest, and we're going to do it the hard way. So what we're going to need to do for a random forest is we first need to get a list of all of our variables that we could possibly use. So this is the same code we used from the IRIS data set. And if you type vars here, this has all of the variables we might want to use to build a random forest. But if you recall, the random forest does not use all the variables. It only uses a random selection. And we're going to just say that the amount we're going to use will be half of them. So I'm going to set the size variable to 22. So that's half of them. So there's about 44, 45 variables here that we can use. So the size will be approximately 22 randomly selected variables. We're going to first build just a regular decision tree like we've always been using throughout the other videos. Let's build a decision tree doing it the old-fashioned way, so that we're going to use that for comparison purposes. So here is a decision tree, and this is an entropy decision tree. Let's print that guy again. There we go. So you can see this is the using an entropy rules for splitting. This is our decision tree. Now we're going to compare against him in a moment. But now let's build a random forest, and we're going to build a random forest with 5 random trees. So tree number 1 will be right here. Let's sample. So we have all of these variables, and we're going to do a sample of them. And so this tree is going to use about maybe 22 variables here. And these are the ones that the decision tree is going to use. Also, we are going to take a sample of our training data set. Now remember, our training data set was 7,000 rows. We are going to use a sample of those 7,000. So let's do that, and let's see what our training data set is. So our training data set is going to be 23 variables because we've got 22 variables in the target, and we've taken about half of these guys. Now let's build a decision tree with them. Now this is what the tree looks like with all the variables and all the training data. Now the random forest builds this. Seems like a more complicated tree. That's interesting. Now let's do that again with another decision tree. We're going to take a different set of variables. Let's just see what it shows. So this time it shows a different set of data, and this is what the tree looks like. And then let's do tree 3. That's a real simple tree. Tree 4. And let's do one more, tree 5. And you could have as many of these as you want, but we're just gonna do the first 5 here. Wow, that's a real complicated looking one, isn't that? Okay, so let's see what, now we're gonna take and predict the probability of crashing your car, and we're gonna use the test data set here. We're gonna see how well this thing did on the on data that it's never seen before. And we're going to come over here. And did I do that for our friend, the decision tree? And I'm back. Yes, I did. I did it right here. I thought I had forgotten that, but no, there it is. Okay, so we're going to predict decision tree 1, decision tree 2, 3, 4, and 5. This is for the random forest. We're going to run those guys. And so we can do, if you see, this is like, those are the predictions for decision tree 1, and we could do the same thing for decision tree 2 if you want. And what we want to do is we're going to average them. So this is our random forest, and we're going to average them. So, and those are the predictions for the first 5, or the first 6 guys. So let's calculate this for the random forest and the decision tree. This is just the vanilla decision tree that we had before. And let's do a ROC curve of just the decision tree. So using the techniques that we've already seen in previous videos with just the decision tree, you can see that this decision tree did a very nice job of predicting who's going to crash their car. Now let's superimpose the random forest and see how that one did. So you can see the random forest in this case did a better job than the decision tree, slightly better job. Now, just I would be willing to bet if I were to do 10, 15, 20 trees, this thing would get even better. But this at least shows you that the decision tree, the random forest, taking a bunch of random trees seems to now improve the accuracy of our predictive model. And if we look at the area under the ROC curve, let's take a quick look here. And you can see that the random forest has an area under the ROC curve. Remember, a perfect ROC curve would be 100%. Pulling names out of a hat would have 50%. But this guy's got an accuracy of 75%, and the decision tree was 72. So we have about a 3% increase this way. Let's now go to gradient boosting. So let's save this and go over here to gradient boosting and see how that one performs. So again, don't do it this way. This is only for demonstration purposes. I'm going to show you in the next video a much simpler, cleaner way to do this. But let's load in all of the data. And we've got 1,000, 10,000 records here. And we're going to want to split this into training and test. And if we do the dimensions of the training data set, 7,000. Oh yeah, it's the same as the other guy. Test, because they started off with the same random number seed. Okay. So what we're going to want to do is let's again build a normal decision tree just like we've done up till now. And let's print that guy. And there's our decision tree again. But now we're going to build the decision tree using gradient boosting. Now recall that gradient boosting uses smaller trees. So instead of 10 levels deep, we're going to say you can't go any deeper than 3 levels. So let's build our first decision tree. And it's a very small, simple decision tree. But remember, this guy uses all the variables. Now we are going to ask the decision tree to give me a list of all of the ones we incorrectly predicted. So in other words, this thing is saying that if you live in the country, you only have a 6% chance of crashing your car. Well, but most people won't crash their car. So that means that some of the people do, this tree is very simple and simply says, if you live in the country, you're never going to crash your car. But you're going to be wrong some of the time. So we are going to come up with a list of all the people we got wrong. And it turns out of the 7,000, we got 1,700 of them wrong. So what are we going to do? Well, we are going to put those guys on top of our data set. We started off with this guy with all the data, and now we're going to add the ones we got wrong. So you can see that the dimension of DF1 was 7,000, and now we've added another 1,700. The ones we got wrong got added to him. Now we got 8,900. Let's build another decision tree. Now we've got another decision tree here, and we got 3,000 of them wrong. So we got to add those guys to the list. And how many do we have now? We've got 11,000 records. And this is our new decision tree. And we're going to keep doing this over and over. Let's build another decision tree. And you'll notice, here's another decision tree, that we are using all of the records, all of the variables, but our records is increasing because every time if you miss somebody, then when you miss it, it gets added to the list. So it gets more votes because the gradient boosting doesn't like getting them wrong. So he's going to keep increasing the importance of the ones we're getting wrong. And finally, here's our last decision tree. And there it is. So now we are going to take all of the ones that we got with our gradient boosting trees and make our predictions. And we are now going to average them all together, and then we're going to also take the decision tree itself, just the vanilla decision tree. Now recall that our gradient boosting trees were not perfect. They were small trees, and the only thing they were trying to do was correct the one before it and try to fix the errors. So let's first look at our vanilla decision tree. And there's the accuracy there. Now, when we bring in all of the gradient boosting trees, let's see how that one did. Significantly better, even did better than the random forest. So What is the area under the ROC curve for this one? The random forest was 75%. This one was 76, call it 77%. So these two approaches improved upon the accuracy of the simple decision tree. Now, that doesn't mean they're always going to be better, but usually gradient boosting and random forest will outperform a decision tree. Very simple models, sometimes the tree will beat those guys. But this is just showing you that putting a random forest or a gradient boosting approach, they are still decision tree based, but they are an ensemble approach, and they will sometimes outperform, or generally will outperform, a simple decision tree. Now, in the next video, we are going to look at a better way of doing this.